Section 1. A light in the dark. The million-sun mystery. Imagine a light so bright, it outshines our sun 1,000,000 times over. Now picture that light hidden deep in the cosmic dark. No beacon was expected there. Then imagine NASA, its powerful eyes on the sky, stumbling upon it. It sounds like science fiction. Impossible energies, celestial enigmas. But this is not fiction. This is astronomical discovery. Section 2. First contact. How the discovery was made. It did not happen with a single, dramatic eureka in a dark control room. It began quietly, in digital streams from orbital and ground telescopes, a fleet designed to see the universe in different kinds of light. Hubble, Chandra, Spitzer. Astronomers noticed an anomaly while cross-matching surveys. Among familiar points, one source stood out. Intensely bright. Intrinsic luminosity, staggering, about 1,000,000 suns even at that distance. Section 3. Anomaly report. Why this signal is so strange. Specific details buried in the data elevated it from interesting to baffling. Not just brightness, the behavior. Rapid fluctuations on short timescales. Stable stars shine steady. Supernovae flare and fade. This source pulsed, hinting at a compact, rapidly changing engine. Location? Puzzling. No obvious massive host galaxy. Its spectral fingerprint was peculiar. It didn't match standard models. It didn't match anything. 1,000,000 sun brightness, rapid variability, unremarkable location, unusual spectrum, a genuine mystery. Section 4. The usual suspects. Active black holes. When brightness is colossal, we look to active black holes. Most large galaxies harbor a supermassive black hole. Gas, dust, or a doomed star can feed the beast. Material forms a swirling disk, heated to millions of degrees by gravity and friction. It glows ferociously before the event horizon, the point of no return. An AGN can outshine its entire galaxy. Accretion is clumpy and chaotic, explaining flicker and flare. But a quasar this bright should sit in a large, visible host. Its apparent absence is a problem, unless the host is faint or dust-obscured. If not steady feeding, perhaps a dramatic one-time meal, a tidal disruption event, a TDE. A star wanders too close to a supermassive black hole. Uneven gravity stretches, distorts, then tears it apart. Debris whips into a temporary, chaotic accretion disk. A brilliant flare. Up to 1,000,000 suns. It rises in weeks to months, then fades over a year or more. TDEs explain brightness and variability, yet some colors and curve shapes don't match perfectly here. Could it be an unusual TDE, or something else entirely? A star, torn apart. Science explores all plausible alternatives, even long shots. A shocked gas cloud could glow across the spectrum, especially X-rays. Collisions send shockwaves that heat and compress gas, but it predicts specific temperatures, densities, and spectral lines. We must consider errors, instruments, processing, alignments. Independent teams confirm or refute the signal across facilities. Speculative notions, new explosions, hypergiants, alien megastructures lack evidence. For now, known physics, black holes and stellar dynamics lead the shortlist. Discovery is the beginning of rigorous investigation. Competing hypotheses are tested, not chosen by preference. If A is true, we should observe X, Y, and Z. Teams return to telescopes, optical, radio, X-ray, to seek those signatures. Long-term monitoring distinguishes TDE fade from AGN variability. Looking with different eyes builds a complete picture. Targets of opportunity mobilize a global network. Peer review and independent checks make conclusions robust. Science at its best, a collective search for truth. As of today, October 18, 2025, the mystery is not fully solved, but JWST and Chandra have added crucial data. The light curve is meticulously tracked. Using JWST, astronomers detected a small, distant host galaxy. We found its home. That points back to in-galaxy phenomena. AGN and TDE remain leading, with hybrid possibilities under debate. Instrumental error is off the table. alien megastructures remain fiction. Focus shifts from what it is to which specific black hole event and why its physics are unique. So, what is NASA hiding? Nothing. They have a puzzle. A cosmic question mark, investigated openly. Most likely, an AGN in a small galaxy, or a recent TDE. Neither fits perfectly, hinting at rare variations or combinations. Science is not a book of answers, but a process of testing and refinement. It starts in wonder, proceeds through detective work, and thrives on collaboration. The story is still unfolding. New data will refine the models. Follow updates, read the findings, and stay curious. The cosmos is waiting.